4 dx. Let me use 1. 1, no. 2 and 6. Yeah. So let's work this out quickly and I'll explain what's happening. So basically what we have to do here, let me use the graph to show you. So if we had the graph, I have my value here as 4. So basically what is happening here, 1, 2, 3, 4. So let me draw my line y equals 4. This line here. So this will be my line y equals 4. So this is basically the line. I can't call it a curve, the line that we're looking at. Y is equal to 4. And we are finding the definite integral from 2. So I'm going to count in 2's. 2, 4, 6. So my boundaries are from here, from when x is 2 to when x is 6. So what shape do I form under that line here? What shape is this? Let me paint it. The area that we're finding, what shape is that? It's a rectangle. So let's go ahead and find the definite integral. And now I'm going to answer your question, sir, when you ask if it's always the area. So remember the steps is basically, do we have any part of the area here under the curve, under the y-axis? The x-axis, sorry. Worry about values canceling. So we do the normal thing. So we integrate. When we integrate 4, what do we get? 4x. So we know, oh boy, it will be 4x. And we take our lower limit 2 or upper limit 6. So in this case, we only have one part to work out and we know we need a difference. So it will be 4, we substitute 6, and then we minus 4, substitute 2. Is this clear to everyone?
Yes, sir.
So
Yes, sir.
4 6 is 24, minus 4 2s, 8, and 24 minus 8 gives us 16. So let's look at this rectangle now. What's the height of this rectangle in terms of units?
4 units.
4 units. What is the width of this rectangle? It's from 2 to 6. So what will be the width?
4, so
4. So if we had found the area, 4 4s would give us what?
16.
16. So I really wanted to show you this, that when we find the definite integral, what we're actually finding is the area. Is that clear with everyone? So whenever you're finding the definite integral, you're actually finding the area between whatever is the curve they give you and the x-axis. But it's important to make a sketch because as I demonstrated in the example before, if a part is below, a part that you're looking at is below, then the negative and the positive can be canceled out while you're doing this working, and you will lose some of your values. And I'm going to show you a prime example of this. So if we have the line and y is equal to, let me do it here. The integral from negative 2 to 2 of x dx. Now this x, again, whatever we're integrating, remember this is our function. So basically we're integrating the function y is equal to x. Right? That's the function we're integrating. Now let me show you what this looks like. Or you know what? Let's find the definite integral before I show you what it looks like. When we integrate x, what will we get?
X squared over 2.
So we'll have x squared over 2. Right? From negative 2 to 2. So let's work this out and see what we'll get. So we'll end up with so we substitute our 2 first, so it will be 2 squared over 2. That's this upper limit I'm substituting, right? Just so that everyone is clear. So we're at x, I put that 2. Minus, now I have to substitute my lower limit, negative 2 squared over 2, which is my denominator. So I want you to work that out and let me know what you got.
0.
0. Now, can you explain why you got 0? Anyone?
One is positive, one is negative.
Yeah.
That's why.
So let me show you what is happening here. Right? So y equal x. If we take the graph of it, you should remember if this is 1, this is 1. Right? So this would be 1 point on y equal x. If this is 2, this is 2. This is another point on y equal x. And then we have 0, 0. So y equal x is this line here. We have negative 1, we have negative 2. So look what's happening here. We want the area under this curve. You see, a part of it is above the x-axis. Is this clear to everyone?
Yes, sir.
And another part is below the x-axis. So
So
is
because-
this very good? So that
Both
is
things
why
is
you
equal. They cancel
Yeah.
out.
correct. That is why you end up with 0. So again, I'm saying if you have to find the definite integral, once it's what must I say? Once it's a function that has a variable, please draw your graph or sketch the graph, because if you don't, you might end up with the incorrect answer. If it's a constant will give you that straight line. So you don't have to worry, nothing will be below. But once it's a curve, it might be below the x-axis. A part might be below. So what do we have to do in this case? Because that would have worked out to 0, and we could see clearly that this area here is not 0.
Find new boundaries and
Very good. So what we'll have to do is to take the int x dx. Well, let me do it the way I did it before. So what would be our boundaries for this part here? This first part.
negative 2, 0.
Wonderful. From here to here. Right? So it will be x squared over 2 from negative 2, that's the lower value, and 0 be the upper value because we are coming in this direction. So when we have finished finding that part, we'll get this area here. How will we get this area here now? What would be our boundaries?
0, 2.
Very good. So it's the same x squared over 2, but we are taking from 0 now, from here to here, 0 to 2. And of course, when we finish working them out, we take the sum. Good. So let's work it out quickly now. This would be minus this first part here, Remember, we'll have to get two values here. Upper limit, lower limit. Plus, for this one here, we also need two values, upper limit, lower limit. Right? I hope you're following.
Yes, sir.
So it would be now, substituting it would be 0 squared over 2 minus negative 2 squared over 2. So that would be to work out this part here. Now to work out this part, it would be 2 squared over 2 minus, yeah, I'm waiting. What will we put here? We're working out this one.
0 square.
Wonderful. 0 squared over 2. So we'll end up with, this will be 0, and we'll end up with 2 2's 4. 4 divided by 2, we'll get 2. It will be a negative 2. But it's negative 2. What is negative tells us is that it's below. So anything you work with something you get negative, it's below. So what we have to do is take the absolute value. The absolute value means we have to take the positive value. It's 2 squares. That's what it means. This negative basically tells us it's 2 squares that are below the x-axis. Is that clear?
Yes, sir.
Right? So we have to take the absolute value. So we're using positive. Plus, again, we'll get 2 here because this will be 0. So it's 2 plus 2, and our answer will be 4 square units. Right? And I can prove to you that our answer is actually 4, because look at this. If I cut out this piece here, let me pretend I'm cutting it out with my orange, and I just translate it up here, it will come up here. Right? So I have 2 units here, and I have 2 units. So you see it's a square we'll make, and 2 times 2 is 4. Isn't that so?
Yeah, I'm
So
curious about something.
Yeah, go
when
ahead.
reading- When reading off the boundaries of the graph, you always put the higher value number at the top.
Correct. Right? We are reading from the left to the right. Remember, 0 is greater than negative 2. Isn't that so?
Yes, that's right.
I prefer to have 0 debt than to owe somebody 200,000. Right? So once you're on the negative, 0 is always larger than that. So I'm just going to show you one more here that may not require. So let's say we were asked to find the integral of x squared from negative 1 to negative 2. To 2. Now, again, right, you do not have to blindly say, you know what, I'm going to take it from negative 1 to 0 and then take it from 0 to 2. You don't have to blindly do that. So what we should do is see what the graph of x squared looks like. Right? So I'll go to GeoGebra. By now you should know what the graph of x squared looks like. Well, I'll still go to GeoGebra so you'll have an idea. Good. So do we have any area below the x-axis here? So do we have to break up this area?
No, sir.
Both will be above, right? So if I'm starting at negative 1, that's here. What's going on? No. All right. So it's basically from here to Here I'm looking. So the area is not found, no part is underneath, so I can just do one working. So I just want to show you this. You don't blindly go and say, I'm going to break up the limits. So the graph looks like this. X-square graph is symmetrical here. And let's say this is -1, -2. So this will be 1 here and 2 here. So the area that we were looking at is, why is this portion here and this portion here. Okay. So let's go ahead and find that area. So what's our procedure?
Integrate x square.
Integrate. So when we integrate x squared, what do we get?
X cube divided by 3.
Wonderful. X cubed divided by 3. Next step. We have
Substitute.
wonderful. Wonderful. So we substitute, right? So we take the difference when we substitute. So it would be 2 cubed over 3 minus -1 cubed over 3. All right, just excuse me a minute. Has anyone worked it out?
Yes, sir. 3.
8. Yeah. So it would be 8 over 3, which would give us what? Excuse me. 3 into 8, 2 and 2/3.
Yes, sir. Plus 1/3.
Good. And -1/3 cube would give you a -1/3, and because of this negative here, it will be plus 1/3. So we end up with 3. Wonderful.
This is even in the worksheet.
Okay. Okay, I didn't know. Yeah, so it will come up to 3 square units. Okay. Okay. Right. So are we go there?
Yes, sir.
Now tell me, if we had split it up, would we have gotten the same answer? What do you think?
No, sir.
You sure?
No.
So what I want you to do, you can try it out.
And then add it.
Yeah. So, and it's clear, this part here is the 1/3, and this part here is the 2 and 2/3.
We get 3.
Yes. So if you had done it from -1 to 0, you would have gotten this as your answer. And if you had done it from, from 0 to 2, this would have been your answer. And when we take the sum of the two parts, you would end up with 3 anyway. Right? Any questions concerning this?
No.